Very good morning to all. Today I have to discuss about the Unit 2 contents, the solar energy technologies. All of them you know basically about the solar energy technologies. The sunrise are to interact with the glass plates and then produce the heat energies. That heat energies is converted into electrical energies. The maximum in nowadays the non-conventional energy sources or otherwise it will be known as a renewable energy sources. This solar energy is the important one. So based upon this unit 2, the solar energy technologies, there is contents have to discuss it in these cases. One is the basics of solar energies, what type of solar radiations and its measurements, and then solar photovoltaic PV systems and its working, and different types of solar cells, PV system components, inverters, and what type of charge controllers and batteries, solar thermal systems, solar water heaters. There is some more applications about the solar energy technologies, and then concentrated solar power, that is like as a CSP power systems, and then applications of solar energy in case of grid connected and off grid connected systems, and solar power devices and IoT applications. These are how to discuss. The first thing have to enter about the solar radiation and its measurements. What's the meaning for solar radiations? How it will be measured means normally measurement of solar energy are typically expressed as total radiations and a horizontal surfaces or as total radiations on a surfaces tracking with the sun. So the radiations data for the sort of electric, like as a photovoltaic systems, are often represented as a kilowatt hours per square meters. That will be simply known as kWh per meter squares. So this solar radiations measurements in terms of kilowatt hour per meter squares. So the generally what's the meaning for radiations? All of them we know. The radiations is one of the three types of heat fluxes. The radiations effects have to created. One is other two types of explained here. One is the heat fluxes, another one is the radiations is thermal energy. So the heat fluxes is nothing but it is always the way of transferring thermal energies and it's expressed in watts per square meters square. Every object emits radioactivity energies. The higher the temperature of the objective or more radiations. In the case of radiations is thermal energy systems. These electromagnetic waves have particular wavelengths and frequencies that properties of the radiations. So these different types of radiations and their effect for the wavelengths. All of them we know about the electromagnetic spectrum. There is a different categories. I guess in your TV itself there is a frequency range is from start from low frequency, high frequency, above high frequency, and then ultra high frequency. That should be categories is there. The same in the case of types of radiations are there. So normally any type of wavelengths to start with the radio waves, micro, infrared, and then visible lights, and then ultraviolet, X-rays, and gamma rays. So normally X-rays and then gamma rays is high sensitive radiations. Like as in your hospital itself, there is a X-ray or any type of CT scan, something like this. In these cases, this type of electromagnetic spectrums have to spray that particular radiations affect in your body and then have to scan something. What all the things will be happen there, I have to discuss. So it is in between the long wavelength, low frequency in case of radio waves, and then gamma rays means short wavelength and then high frequencies. So these time durations will be very less in terms of milliseconds or nanoseconds. That will be happen there. That's radiations will be aligned. So in these cases, the 49% consists of infrared wavelengths, and then 43% consists of the visible wavelengths, and then 7% consists of the violet wavelengths, and then greater than 1% consists of the radio waves, and then microwaves, and then extras or gamma rays. This will be very harmful one. Based upon that, how the radiations in between the two bodies are to measure, that's a general formula. That is Q12 equal to F12. That is a multiplication of A1 and then Q multiplications of T1 to the power of 4 and then minus T2 power of 4. In these cases, the Q12 is known as a radioactive heat from the body, one body to another body. And then F12 is indicated for the transfer factor from the body conditions. And then A1 is the radiative surface of your body in terms of meter square. And then T1 and T2 is interface in between the temperature of the body 1 and the temperature of the body 2 surfaces. So this is a basic thing. The radiation's effects will be vary means any changes in the case of body temperature that will be happen there. So in this case, the different type of solar radiation measurements also there. That is a as per in your plus two, there is a different informations in the graph studies. Like as direct normal, that means like as what you call geographical energy waves and some other things. So in these cases, the way of different types of solar radiation measurements, the values is always focused on that particular glass and then direction of the reflecting glasses then only reflect to the sunlight itself. So when the GHI is equal to DNI plus DHI, that is GHI is nothing but global horizontal irradiance, and then DNI is the direct normal irradiance, and then DHI is the diffusion horizontal irradiance. That will be the reflect from the one plate to other plate. So based upon that, the radiations have to measure in the case of solar energy systems. So in these cases, the different type of solar, how the energies have to collect from the particular solar plate means there is a different type of collector should be there. One is the stationary collector, that is also known as a non-concentrating type, and stationary collector is the concentrating type. Another one is the sun tracking system. So in these cases, the different types of energy, solar energy collectors, based upon the stationary and then single axis tracking and then two axis tracking, how the concentration ratio and then indicating the temperature ranges have to vary. In the cases stationary is the minimum temperatures have to indicate it up to 30 to 80 degrees centigrade. But in the case of two axis tracking system, as per the table, it will be up to having the maximum temperature up to 152 to 2000 centigrade systems have to collect in particular plates itself. So in these cases, the different comparisons of energy absorbed for the various modes of tracking. One is the full tracking system, another one is the east-west polar system, another one is the north-south horizontal axis, another one is the east-west horizontal axis. So in these cases, the solar energies and then percentage of full tracking systems, how much of energies have to develop are shown in the table. So in these cases, E is indicated for the equinox, and then S is indicated for the summer solstice, and then W is indicated for the winter solstice. So both the winter and then summer seasons, how the full tracking systems, how much of tracked percentage of solar energy through the temperature changes will be produced are shown in that particular table. Thank you. I have to discuss in the next other portions. I have to discuss in the next classes.